Volume of pyramids. Okay, so when finding the volume of a pyramid, why is it important to find the shape of the base of the pyramid? That's my central question for today. Now, by this point, you should have already seen in class the inquiry lab. I showed you about comparing a cube. We took a cube with the same measurements, right? I think there was 2 inches each. And then we also took a pyramid with the same square base, right? Same square base as the cube, except it was a pyramid. It looks something like this, right? And we decided, hey, which one had the most volume? And we said, hey, this one's smaller, so how many of these would fit into there? And so that brings us to our volume of a pyramid. The volume of a pyramid is 1/3 the area of the base times the height. Okay, there's 3 of these. Times it by 3 will fit into a cube with the same base measurement. Okay, and this is the formula for that. Volume is equal to 1/3 big B. Remember, the big B indicates that it is made up of 2 things, so it's made up of an area of the base, and you times it by the height. Okay, so each side of a 3D shape is called a face. 3D, 3-dimensional, right? Talking about 3-dimensional. Each of the sides are called faces. Okay, any face that's not a base, if it's not the base, it's considered a lateral face. So what do I mean by all that? Well, let's take a look. If I look at this pyramid, for instance, the very bottom here, that's considered the base. And all the 4 other sides that make up the different faces are called lateral faces. I'm sorry, I had to take a break. I had to get the phone. Anyway, so like I mentioned before, anything that's not the base is considered a lateral face. So if you ever hear me saying that, you know what I'm talking about. What I did is I took the shape and I kind of just cut it down the lines, and you could see that the base on the bottom, and then the 4 other sides are called lateral faces. Let's try on an example. So find the volume of the pyramid. So here's my pyramid. There's my base on the bottom, and then the height, which is perpendicular to the base, goes from the tip all the way down to the base, or that's my information. So I use my formula, 1/3 of the base times the height. So here I go. The base happens to be this rectangle, right? Parallelogram. So I know I'm just going to take 3.4 times it by 1.2. That's what I did here. Okay. My height is 2.5, and then I just do 1/3 of all that. So I go ahead and multiply these 2 together first, and then I multiply these 2, and then last but not least, I divide it by 3. And so again, notice that the parallelogram is the base of the shape. So that's why I used base and height, right? These 2 right here. The volume happens to be 3.4 inches cubed. It's a 3-dimensional shape. Now let's try one more. It's slightly different. The volume of this pyramid. It's another pyramid, but take a look. This one looks different than the other one. What's the difference between these 2? Ask yourself. Well, the big difference is this one down here does not have a parallelogram as a base. Its base is a triangle. So notice the difference. This time I use a slightly different formula for my base, right? Last time, go above here, I just did 3.4 times 1.2, right? It's the area of a rectangle. But this time it's a triangle, so I have to do half of 8 times 6, right? This is the height of the triangle, base of the triangle, so 8 times 6 cut in half. So all this blue part here is just the area of the base. My height is 12 meters, okay? And then I do 1/3 of all that when I'm all done. And so I end up with 96, so the volume is 96 meters cubed. Cubic meters. So we'll get some more examples and practice of that in class, but let me just take it to one further level here. Let's find the missing height this time. So what if I gave you the volume of a pyramid? I know it's a pyramid, and I gave you the total volume already. I want you to work backwards and find the height. All right, so let's take a look. Here's a pyramid. You can see the base and measurements, but what I don't give you is the height. I tell you that the volume is 90 inches cubed, so what I can do is I can set up, remember my formula is 1/3 area of the base times the height. Well, I know my volume, it's 90, 1/3. My base is just 5 times 9, but I don't know my height. So I go ahead and simplify. I take 1/3 of 45, and then last I say, hey, this says 90 is 15 times the height. 15 times what gives me 90 is what you should be asking yourself. So we're going to use a little bit of algebra here and solve this. You say to yourself, wait a minute, let's reverse this. Instead of saying times, what if I do the opposite and I do the inverse operation? Instead of 15 times h, I'm going to divide by 15. Whatever you do to one side, do to the other. 90 divided by 15 is 6. That makes sense. 6 times 15 is 90. So therefore I worked backwards and I found out what the missing part was. Now I know the height of this pyramid is 6 inches. Okay, this is our last example here. I know I'm going by quick, but just get this into your notes and it'll help you out. Okay, the volume of the pyramid is 44 meters cubed. To find the missing heights. Once again, I take a look. The big key here is this base is not a rectangle, but it's a triangle. So I know that the volume is equal to 1/3 base times the height. In this case, the base is a triangle. A triangle, we take 1/2, 3 times 8, right? 3 times 8, half of that would be to give me the area of this base. All right, so there it gives me 12. 1/3 of 12 is 4. And then again, I do the inverse operation and divide both sides by 4 and I find out that the missing height had to have been 11 meters. Okay, so be ready. Make sure you get those notes in and be ready with questions tomorrow so we can discuss more about this.